Okay, in this video, we're going to learn about probability distribution, the last chapter. Okay, so under this topic, we will look at probability distribution for two random variables, which are discrete random variable and continuous random variable. Okay, before that, recall from chapter 1, what is meant by discrete and continuous random variable. So recall, discrete variable is variable that arise from counting process. Okay, for example, we have number of kids in a house, for example. Okay, so number of kids you need to count. For example, 1, 2, 3, 4, and so forth. So that is discrete. While continuous random variable is a variable that arises from measuring process. Okay, for example, so we want to know our weight. So how we measure our weight using the weighing scale. Okay, so that one will based on measuring process. So later on under this topic, we will look at on how to find probability distribution for both discrete and continuous random variable. Okay, now look at some introduction first. In any experiment, there are numerous characteristics that can be observed or measured, but in most cases, experimenter will focus on some specific aspect or aspects of a sample. So in general, each outcome of an experiment can be associated with a number by specifying a rule of association. So such rule of association is called random variable and it is usually denoted by a capital letter. For example, we use capital X or Y, or it also can be any letter, okay? Okay, now look at what is meant by random variable. So a random variable is a function defined on a sample space. So if S is a sample space with a probability measured and X is a real valued function defined over the element of S, then X is called a random variable. So later on we will look at some examples in detail. Okay, now here look at some simple experiments. Okay, the first one, the experiment is observing percentages of completed project of building a new school. So what is the random variable? So recall what is variable in chapter 1. So variable is defined as characteristic or what we want to study. Okay, so in experiment 1 here, so we want to observe about percentages of completed project. Okay, so the variable here will be the percentages of completed project. Okay, now look at next column. We have possible values for the random variable. Okay, so let's say this random variable, we denote it by capital X. So possible values for X. So our variable just now is percentages of completed project, right? So example of possible values, it can be 0%. 0% means that the project is not started yet. Okay. If 100% means that the project already completed. Okay. Or value X also can be 50%, 70%, and so forth. Okay, next experiment. Inspect 40 calculators of a class to look for the number of defective calculators. So what we want to study in this experiment? So we want to look at the number of defective calculators. So number of defective calculators here will be the random variable X. Okay, so we want to study or we want to inspect the number of defective calculators. Okay, possible values for X. Okay, so for this experiment, X can be equal to 0. 0 means that number of defective calculator. If X equal to 0 means that there is no defect calculators. Okay, and X equal to 1. X also can be equal to 2 up to 40. Okay, so in this case, value X can be up to 40 because here we only have 40 calculators. This one, value X, why from 0 until 100%? Because we want to observe about the percentages of completed project. Okay, so it can be the logic value is from 0 to 100%. So this one, the logic value for value X is from 0 until 40 because we have 40 calculators only. Okay, next experiment, toss 2 coins and then we are looking for head. So what we want to study here? We want to look at number of heads. Okay, so the random variable here will be number of heads. So possible values for X. Okay, if we toss 2 coins, what is the possible value of X? Means that what is the possible value for us to get head? So either X equal to 0 or X equal to 1 or X equal to 2. X equal to 0 means that we will get tail. Okay, so means that like this. Tail. Okay, tail means that X equal to 0. Why equal to 0? Because now our variable X is we want to look at number of head. Okay, X equal to 1. What does it mean X equal to 1? So let's say you toss 2 coins, you get tail head. Okay, you get tail head or either you get head tail. Okay, so that is made by X equal to 1. Head equal to 1 here and here also head equal to 1. Okay, what about X equal to 2 here? If X equal to 2 means that we get head. So that is meant by possible values for that random variable. Okay, last experiment example here. Observe cars passing a checkpoint. So the random variable will be number of cars passing a checkpoint. Okay, so the possible values can be from 0 or 1, 2, 3 and so forth. So means this one until infinity. Okay, why until infinity? Infinite because we do not know how many cars will pass the checkpoint. So that's why here until infinity. So here finite numbers until 40 only because we only have 40 calculators. Okay, this one types of random variable as I explained before. So we have two, discrete and continuous. Okay, discrete based on counting process and continuous based on measuring process. Okay, now look at example. Simple exercise in classifying whether the variable is continuous or discrete. So look at A, let's say the random variable X here, the number of automobile accidents per year in Kuala Lumpur. So classify whether it is discrete or continuous. Okay. So now our random variable X is the number of automobile accidents. So number of automobile accidents here will be discrete or continuous. So this one will be discrete. Okay. Okay, B-Y, the length of time to play 18 holes of a golf. So what is the random variable here? So the random variable will be length of time to play. Okay, so if time we measure or we count. So here will be based on measuring process. Okay, so means that we will look at our clock or you will set a timer. Okay, so here will be continuous. Okay, see the amount of milk produced yearly by a particular cow. The amount of milk, for example, liter in liter, okay, or in gallon. So this one will be continuous as well. Okay, the number of eggs laid each month by a hen. So number of eggs. The number of eggs for sure we count, right? So here will be discrete. Okay, E, the number of building permits issued each month in a certain city. Number of building permits. So here also will be discrete. So we count. Okay, last example here. The weight of grain produced per acre. Weight. So weight we measure. Okay, so here will be continuous. Okay, that is some examples on how to classify discrete or continuous variable. So remember, discrete can take integer number only. Okay, for example, number of automobile accidents. So for example, x equal to 10. So you cannot have value x equal to 10.3. Okay, number of automobile accident cannot be 10.3. Okay, so that is discrete. Okay, if continuous, for example, amount of milk produced. Let's say M, the random variable will be amount of milk produced. So continuous value M, it can be 1 liter, 10.2 liter, or it can be 0.7 liter, and so forth. Okay, now look at this example. Okay, 2 salts are selected at random and removed in succession from a drawer containing 5 brown salts and 3 green salts. Okay, find the probability distribution for X, okay, where X is the number of brown salts selected. So now our random variable X referring to brown salts, okay. Okay, how to construct the probability distribution? So here in terms of the probability distribution will be formed in terms of table. Okay, we will display the probability distribution using table. Okay, extract the info given first. So here we have 5 brown salts, 5, and then green salts 3, so I put G equal to 3, so total will be 8, 5 plus 3, 8. Okay, 2 salts are selected, so we want to choose 2 salts only. Out of 8, we want to choose 2. Okay, so if you still remember from previous chapter, I'm referring to number of selection. And our random variable X referring to number of brown salts selected. So let X equal to number of brown salts selected. Okay, for this type of question, it is easy for us to use tree diagram in order to get the probability distribution. Okay, now look at on how to draw the tree diagram for this experiment. Okay, since number of selection is 2, so later on we will have 2 branches. Okay, so this is the first selection. Okay, so this is first selection. So here either we choose brown salts or here we choose green salts. And then second selection also will be like this. Either you choose brown salts or here we choose green salts. So this is also the same. Either we choose brown salts and either we choose green salts. So you put label here brown, green, brown, green. Okay, then put what are the possible outcomes. Okay, so the outcomes here will be so here either we get blue, okay, we want, sorry, not blue, brown, okay, brown. So you want to choose 2, right? So either we get both brown or we get here brown, green, or here we get green, brown, or last one, both are green, GG, okay? Okay, how to put the probabilities? Look at how to get the probability. So recall how to calculate probability is number of items or number of events in that experiment divided by total all. Okay, for the first selection here, so let's say I put here first selection. So here is first selection. Here is second selection. Okay, now look at how to get the probability. For example, what is the probability to get brown socks on the first selection? Okay, so recall how to calculate the probability, number of items or number of events in that experiment divided by total sample space. So here, probability for us to get brown sock in the first selection will be, so brown sock we have 5, total socks is 8, so it will be 5/8. Okay, so that is the first probability. Okay, green socks we have 3, probability is 3/8. Okay, so total all or total sample space is 8. Okay, so remember, so each branch here, total probability must be equal to 1. So 5/8 plus 3/8 is 8/8, which is equal to 1. Okay, now look at how to get probability to select brown sock as well on the second selection. Okay, so what is the probability? So first selection we already take brown socks, right? So means that we only have another, means that the brown sock will be led by 1. Okay, so we have another 4 brown socks. Okay, here we already take 1, so on second selection means that we only left with 4 brown socks. So 4/7. So why over 7? Because we already take 1 sock here. Okay, so that's why 4/7. So here what is the probability? Okay, so here we choose brown sock, right? So meaning to say that green sock we still have 3. So here will be 3/7. So again, total probability for each branch must be equal to 1. 4/7 plus 3/7 equal to 7/7, which is 1. Okay, how about this? Choose brown sock on second selection given that first selection is green. Okay, so look at here. First we choose green, right? So how many brown sock that we have? 5. 5/7. Okay, why 5? Because here we choose green, so meaning to say that we have another 5 brown sock here, because here we choose green. Why over 7? Because we already take 1 sock, which is green. So green, so we take 1 green here, so here will be 2/7. So 5/7 plus 2/7 equal to 7/7, which is equal to 1. Okay, so you must check the tree diagram must be correct. Okay, total probability cannot be more than 1. Okay, now look at what are the possible values of x. Okay, so this is the outcome. Okay, what is possible values of x? Okay, let's say here I put x. Okay, so this is our random variable. So x is now referring to number of brown socks. So the first outcome is brown, so x will be equal to 2. Brown, green, so x equal to 1. Green, brown, x equal to 1, because 1 brown here. And last one will be 0. Okay, because we get both green socks. So GG, there is no brown, so value x equal to 0. So the possible values of x in these examples are 0 or 1 or 2. Okay, so that are the possible values of x. Okay, now look at how to find the probability. So let's say I put here probability of x. So x referring to brown socks. X equal to x. Okay, so x referring to brown sock equal to x here referring to possible values of x here. Okay, how to calculate the probability? So you apply the Bayes theorem based on tree diagram. Okay. So probability for us to get brown is 5/8 multiplied by 4/7. So this one we will get 5/14. So similarly, what is probability to get brown green? 5/8 multiplied by 3/7. So this one we will get 15/56. And what is probability to get green brown? 3/8 multiplied by 5/7. So this one also will be equal to 15/56. Okay, the same thing. Okay, when x equal to 1, you will get the same probability. Brown, green, green, brown. And last one, probability for you to get both green is 3/8 multiplied by 2/7. So this one is 3/28. Okay, and when you total up, okay, the probability must be equal to 1. Okay. So you total up here 5/14 plus 15/56 plus 15/56 and plus 3/28. So at the end, total must be equal to 1, okay, which is total probability. Okay, now we will construct the probability distribution based on this tree diagram. Okay, construct the probability distribution. So the probability distribution is, okay, you put into table, okay, table like this. Okay, x, which is referring to brown salt, so the possible values of x here will be either 0 or 1 or 2. Okay, so here you put the probability. Probability of x equal to x. You can use any letters, okay, y, a, B, C, and so forth. But normally we use X or Y. Okay. Okay. What is probability to get 0? X equal to 0. 0 means we get both green. So the probability is 3/28. 1 is, so 15/56 plus 15/56 is equal to 30/56. So if you simplify, 50/56 will be equal to 15/28. So you put in simplest fraction also, no problem. Okay. So if you put as 30/56 also, no problem. Okay, 2 probability is 5/15. So if you total up 3/28 plus 15/28 plus 5/14, so total probability must be equal to 1. Okay, that's how we construct the probability distribution for a discrete random variable. Okay, so what is the discrete random variable in this case? The number of brown salt selected. Okay, so discrete cannot be in fraction or cannot be in decimal point. Okay, so means that this value x cannot be in fraction and cannot be in decimal point. So for example 4 and example 5, you try to do it on your own. Later on, I will give you the answer. Okay, now let's look at this example. A mail-order computer business has 6 telephone lines. Let X denotes the number of lines in use at a specified time. Suppose the probability distribution function of X is given in the accompanying table. Okay, so in this example, a probability distribution for each value of X already given. Okay, so previous example, a situation is given and then we need to construct the probability distribution table. Okay, now let's look at the question. Okay, calculate the probability of each of the following events. So A, find the probability at most 3 lines are in use. Okay, so how to answer this one? So calculate probability. So P x, where x referring to number of lines in use. Okay, at most 3 lines. So if at most the equality sign will be less than equal. Okay, so at most 3 lines, so less than equal to 3. So what is x less than and equal to 3? So will be probability of x equal to 0 or plus probability of x equal to 1 or probability of x equal to 2 or probability of x equal to 3. Okay, so that is at most 3 lines are in use. Okay, then you put the probability for each value of x. So if x equal to 0, probability 0.1 plus 0.15 plus 0.2 plus 0.25. So here the probability, the answer is 0.7. Okay, so that is at most 3 lines are in use. So if at most less than equal. Okay, now let's look at B. Fewer than 3 lines are in use. Probability of x fewer than 3 lines. So if fewer will be less than 3. So what is less than 3? Probability of x equal to 0 or so plus probability of x equal to 1 plus probability of x equal to 2. Okay, fewer than 3. So if fewer than 3 will be 0, 1 and 2. So 0, 0.1, x equal to 1, 0.15, x equal to 2, 0.2. So the probability is 0.45. Okay, next question C. Find the probability that at least 3 lines are in use. So if at least, probability of x, so at least will be greater and equal. So what is greater and equal to 3? So will be start from x equal to 3 or x equal to 4 or x equal to 5 or x equal to 6. Okay, because we have 6 lines only. So x equal to 3, the probability is 0.25. 4, 0.2. 5, 0.06. And 6, 0.04. So this one, the probability is 0.55. Okay, if you look at question B and question C, so actually question B is complement for question C, or we can say that question C is complement for question B. Okay, so question C, you also can do like this. So if at least 3 lines are in use is greater equal to 3, right? So you can use complement rule. Okay, greater and equal to 3 is 3, 4, 5 and 6. So you use complement rule. Total probability is 1. So 1 minus x equal to 0, x equal to 1 and x equal to 2. Okay. So in this case, you also can do like this. Or probability of x at least 3, so greater equal to 3. So this one also equal to total probability 1 minus probability of x less than 3. Okay, less than 3, or you put x less or equal to 2 also will be the same thing. So what is x less than 3? So will be 1 minus probability of x equal to 2 minus probability of x equal to 1, and last one is probability of x equal to 0. Okay, so 1 minus, so if x equal to 2, x equal to 1 and x equal to 0 is actually from question B, right? So 1 minus 0.45. So here also you will get 0.55. So don't get confused here. So here is actually 0.5. Here is actually you total up this one. Okay, like this. So this one if you replace by positive sign. Okay, so negative positive will be negative. Okay, so this part in bracket is actually from question B. Okay, next question D. Probability of between 2 and 3 line inclusive. Inclusive means that value 2 and value 3 is included. Okay, so between 2 and 3 lines inclusive are in use. So this one how to write? So probability of 2 x greater equal to 2. So here will be like this. Okay, so x greater equal to 2 but x less than equal to 3. Okay, so x here less equal to 3, here greater equal to 2. So what is the value between x equal to 2 and 3 inclusive? So here will be probability of x equal to 2 plus probability of x equal to 3. So x equal to 2 is 0.2. X equal to 2, 0.2 plus 3, 0.25. So the answer is 0.45. Okay, now let's look at question E. Find the probability that at least 4 are not in use. So question gives us x referring to in use. Okay, so here what you can do first, let's say I define here x, let x is in use, y not in use. If you want to use x prime also, no problem. Okay, what is if probability at least 4 are not in use is like this. Probability of not in use is y. So you put y at least greater equal, okay? Greater equal to 4. So this one, how to find not in use? So you can list like this. Okay, at least 4 are not in use. So the combination that you can relate with in use is 4 not in use also will be equivalent to 2 in use. Okay, y not in use, x in use. So total we have 6 lines, right? So if 4 are not in use, meaning to say that there is another 2 line which is in use. Or at least 4. So 4 not in use, so another combination will be, maybe there will be 5 not in use, so not in use is y. So if 5 not in use also will be another 1 line will be in use. Okay, so 1x, let's say I put here. Because total line is 6. Or, okay, why or? Because at least 4 here. 6 not in use, see 6 not in use, 6y. So if 6 not in use means that all lines are free. So which is equivalent to 0, x. Okay, when x equal to 0. So probability of y at least 4 are not in use. So y greater equal to 4. So this one you can use. You can refer to x here which is in use. So 0, 1, 2. So this one will be equivalent to x at most or equal to at most 2. Okay, so at most 2 is probability of x at most less than equal to 2. Okay, so what is less than equal to 2? Probability of x equal to 2 or plus probability of x equal to 1 or plus probability of x equal to 0. So what is the probability? If x equal to 2, the probability is 0.2 plus if x equal to 1, 0.15, and if x equal to 0, the probability is 0.1. So probability is 0.45. Okay, now let's look at this example. So this example, it gives you a formula, okay? So first example, we construct the probability distribution table where we put it in the form of table. Second example, the probability already given to us. So this example, an equation or the formula of the probability is given. Okay, so now look at how to find the probability distribution for this discrete variable. Okay, look at the question here. The probability distribution of a random variable k is given by probability of k equal to jk square. Okay, so now our variable here is k, where k start from 0, 1, 2, and 3. Given j is a constant, so j is a constant, find the value of j and hence the probability distribution of random variable k. Okay, how to find this probability distribution? Okay, so we need to substitute value k into this formula. Okay, so to ease you, you directly construct the probability distribution table. Okay, construct a table like this. So here you put value k. Okay, so capital K is our variable. K equal to k. So k is lowercase k here referring to value k. So value k start from 0, 1, 2, and 3. So here will be total. Okay, total probability. So remember total probability must be equal to 1. Okay, here you put the probability. Okay, probability of k equal to k. Okay, how to find this value? Okay, first we substitute. Now we want to find value j. Okay, the constant value. Okay, we substitute value k into this formula first. Okay, this formula. Okay, if k equal to 0, what is value j? So 0 square 0 multiplied by j will be 0. So here will be 0. Okay, if k equal to 1, substitute to this formula. 1 square is 1, 1 times j is j. So if k equal to 2, 2 square is 4, 4 times j we get 4j. If k equal to 3, so 3 square 9, 9 times j we get 9j. Okay, so what is the total here? So we know that total probability equal to 1, but now we do not know what is value j, okay? So j plus 4j, 5j, 5j plus 9j is 14j. So how to find value j? 14j equal to 1. Okay, total probability is 1. So j equal to 1 over 14. Okay, since we know that j equal to 1 over 14, then we can find what is probability for each value of k. So here you put probability of k equal to k. So when k equal to 0, the probability is 0. When k equal to 1, the probability is j. So what is value j just now? 1 over 14. Okay, when k equal to 2, the probability is 4j. So what is the probability here? Value probability. So 4 multiplied by 1 over 14. So here you will get 4 over 14. And last one, if k equal to 3, the probability is 9j. So since we know that j is 1 over 14, so the probability when k equal to 3 is 9 multiplied by 1 over 14, which is 9 over 14. So if you total up, probability must be equal to 1. Okay, so 9 plus 1, 10, 10 plus 4, 14. So 14 over 14 equal to 1. So this is an example of probability distribution if a formula or equation is given to us.